To start off with, let's use the analogy of a stock price. If you just have one stock price on one date, that's pretty meaningless data, right? But if you put it with a bunch of them, and then you can analyze how the stock is performing over time, then it becomes meaningful data, and you can actually look for patterns in that data. And how you contain and what data structure you use for that data is really important in computer science. So a data structure is just a container for data. And like in the real world, we have stuff. So I have this coffee thing, and I can store this in a fridge, or I can store it in a backpack. Both of these have strengths and weaknesses. For example, a fridge is massive, right? But it keeps things cold, and it's also really organized. Or you have a backpack. A backpack's really portable. You can just chuck a lot of stuff in there, take it wherever you want, but it's not so organized. It's the same with data structures. The reason there's loads of data structures is because there's no perfect one, and they all have different strengths and weaknesses dependent on what you want to do. As a computer science student or as a programmer, you're given some data and you're told what we need to do with the data. You can look at it and say, okay, we're going to use this data structure, and you understand the strengths and weaknesses of each one.